Hello, PreAlgebra. So we are ready for lesson 3-2, classifying real numbers. Now this is going to be the last lesson of this unit, which means get ready. You're almost up for a test. So if you get done with this super early or anything, please go ask the substitute for a copy of your study guide, and she will be happy to give that to you, and you can start working on the study guide a little bit early, or you can go back and maybe do some corrections on your old work or something like that. So let's talk about real numbers. Well, what in the world is a real number? I thought all numbers were real, right? Well, there's some numbers that aren't real. There's some numbers that we call imaginary, which you're going to get into in Algebra 2. We're not going there today. So we're just going to talk about the real numbers, not the imaginary ones. So let's talk about real numbers. Well, let's start with the first numbers that you learned how to count. When you were a little bitty baby, you started to learn to count with 1, 2, 3, 4, 5, and so on, right? Those are called natural numbers. And so on. So 1, 2, 3, 4, 5. You eventually learned up to 100. They just continue. The natural numbers, they're all there. Okay. So then you got into school and you started learning about the concept of zero, or maybe even before school, you learned that there was something when you have nothing. There's actually a number that represents that. So we're going to add that into the natural numbers, but that's going to make a whole new set. So we're going to call these whole numbers. Now, whole numbers, remember, they're all of the natural numbers and 0. So 0 plus all of the natural numbers. Then you grew up a little bit more, and maybe in probably 4th, 5th grade, you started learning about the concept of owing people money, or maybe going up and going down, all those things, ascending and descending, profit and loss. You start learning about the concepts of negative numbers. Okay, negative numbers then are after whole numbers. They include all of the natural numbers. Our next set includes 0, but it also includes all of the negative numbers. So our next set is called the integers. We've been talking about these this week, so you should be pretty familiar with integers. So remember, integers include all of the natural numbers, all of the whole numbers, which are just all the natural numbers plus 0, plus they include all of the negative whole numbers. So integers are getting pretty big, right? Okay, there's 2 more sets that we have to do. So we have natural numbers. Those were the ones that you learned when you were a baby. Whole numbers, when you started learning the concept of 0 plus all of the natural numbers, you don't forget them, right? And then you learn about integers, so that includes all the whole numbers and the natural numbers, because, again, we don't forget them when we learn something new. So now, when you were in 6th grade, you started learning the concepts of fractions and decimals, so parts of numbers. So parts of numbers are called rational numbers. So rational numbers, of course, they include all of the integers. And they include all of the whole numbers. They include all of the natural numbers. Plus, they include all of the parts of numbers, which would be fractions and decimals. Well, most decimals anyway. But there's a few decimals that aren't going to fit in here. So just to clarify, we've been talking about classifying real numbers. All of these are known as real numbers. Crazy, right? Okay, so let me erase the board really quickly, and we'll go a little bit farther into rational numbers. Okay, so I just want to talk about rational numbers right now. Now we said rational numbers include all the naturals, all the wholes, all the integers, and fractions and decimals. Well, there's some decimals that don't fit in this category. So let's talk about the ones that do. So a decimal either has to terminate, it has to end, or it can be repeating. So for example, if I have 0.6 or 6/10, it ended, right? There's nothing after it. It just stopped at 0.6. It's done. So that is what is called a terminating decimal. It's a decimal that stops. The other one that fits into rational category is the repeating decimals. So this is like if you had the fraction 1/3 and you went and divided that, it would end up with 0.33333 forever and ever and ever. And we use that line on top to show that that's repeating. So repeating decimals are also included in rational numbers, but they're not terminating. They don't stop. They go on forever, but they repeat. So these are always going to be able to be written as fractions, so therefore it's going to be included in the rational numbers. So these are called repeating decimals. And also in rational are going to be all of our fractions. Don't forget that our natural numbers are included. Our whole numbers are included. And our integers are also included. Okay, so rational is a big group. So we learned all of these. We're going to learn one more group that doesn't fit into this category. So they're called the irrational numbers. These are not pretty numbers. You know a few of these, but you probably didn't realize that they were irrational. So irrational numbers never repeat, right? Decimals that never repeat. And they do not terminate. They never stop. They will go on forever and ever and ever. So can you think of anything that would go in there? Never repeats, never terminates. There's one that I know that you know. It looks like this. You know that number? Pi, right? Pi will never end. As far as we know, there have been computer models that have been calculating pi for a long, long time, and we have never found an end to pi. It continues forever and ever and ever. Therefore, it does not fall into that rational category because it does not terminate and it doesn't repeat. It is different numbers every time. So pi is one of those. We're going to be talking more about square roots later on in the year, but just know that the square roots that do not come out to perfect squares are also included. The square roots that do not terminate would be like the square root of 3. We're not going to get into those real heavy right now, but those really weird numbers like, your primes, those are all going to fit into that category. So irrational numbers. So now we need to talk about how to classify them. So you are going to be given an iNotebook piece, and we're going to go over to the camera and we're going to fill that out. And then we'll come back and we'll talk a little bit more about what examples we need to do for classification.
So you should have one of these papers by now. There were 2 to a paper, so it's 1 paper for 2 people, just like we've been doing. And we're going to fill this out and kind of go over some of the problems, and then you're going to tape this into your iNotebook. So real numbers, in words, real numbers consist of rational and irrational numbers. So we haven't looked at anything quite like this, and I've got a little bit better of an example in my opinion, but we're going to go ahead and put some things in this to hopefully make you understand it a little bit more. So in the whole numbers, now notice there's no natural numbers in this one. Natural numbers would actually go inside of whole numbers, but we're just going to put them together for this one. So natural whole numbers are 0, and our natural numbers are all of our counting numbers, right? So integers then include all of the whole numbers, see how they're inside, and they also include all of our negative whole numbers. Rational numbers then are going to include our ending decimals or terminating decimals. It will include repeating decimals, and it'll include fractions. The fractions and the decimals could be positive or they could be negative. In rational numbers. So this whole thing all together is real numbers, because we're not talking about imaginaries. And then irrationals are the ones who do not terminate and they don't repeat. So that would be like pi, or that would be like 1.2456. Notice how it doesn't repeat. And then we're going to continue. The ... means it's going to continue forever. And this also includes certain square roots, like the square root of 2, the square root of 3, the square root of 5, the square roots that are not perfect squares. So rational numbers can be written as a quotient of numbers. That's just a fancy way to say they can be fractions. Irrational numbers cannot be written as fractions, so they cannot be written as a quotient of numbers. And they can be written as a decimal that ends or repeats. Irrational numbers cannot be written as a decimal that ends or repeats. They would have to go on forever and ever and ever for it to be irrational. Okay, so before we do this bottom, I'm going to tell you a story. So here's my story. So we're going to go to school. We go to school every day. So I'm going to draw my school bus here. And yeah, I've been known that I'm, a wonderful artist. So I hope you like my school bus. Okay, there's my school bus. And over here is our school. And the bus is going to make several stops before it gets to the school. So our first bus stop is going to be for natural numbers only. Our second bus stop is going to be for whole numbers. Now we know that natural numbers are also whole numbers, so yeah, that can be either one of those. And then our third stop, our third bus stop is going to be for integers. And our fourth bus stop is going to be for rational numbers. Those are going to be those fractions and decimals. So as our bus is going to school, it has to stop and make these stops. Now, here's the thing. If a number is a whole number, it has to ride the bus for the integers and the rationals before it gets to school. So we know that, let's say we're trying to classify, let's classify 5. So we know that 5 is a natural number. It's one of those counting numbers we learned when we were little kids. So if it gets on this bus stop, it's got to ride the bus to the whole numbers. So we know it's natural. It's got to ride the bus to the whole number stop. It's got to ride the bus to the integer stop. And it's got to ride the bus to the rational stop before it gets to school. So if you're going to classify 5, we know it's natural, whole, integer, and rational. Let's try another one. Let's classify -3. So -3 is not a natural number, so we can't stop there. It's not a whole number, so we can't stop there. It is an integer. So we're going to stop at the integer stop. And because it stops at the integer stop, it has to ride to the rational stop before it gets to school. So we know that -3 is integers and rational numbers. Let's try one more. So we're going to classify 2/3. Well, 2/3 is a fraction. It's not a natural number. It's not a whole number. It's not an integer, but it is rational. So this one doesn't get on the bus until the rational stop. And because it doesn't get on the bus till the rational stop, it doesn't have any stops before it gets to school. So therefore, it's only a rational number. So let's talk about one more really quickly. So if we're going to classify pi, we know that pi is an irrational number. Well, irrational numbers don't have a stop. Here's why. Irrational numbers are over here on their own. They are car riders. Because they're car riders, they can only ride directly to school. They don't get on the bus because there's no bus stops for car riders. So if you're going to classify pi, we know that it's an irrational number. It's nothing else but an irrational number because there's no stops that it's going to be making. So we're not going to put I here for irrational because remember, I is integer. So we don't want to use I for irrational. So we're actually going to write out irrational as a classification. Okay, so think bus stops. So let's look at these other examples that they have here. So we have pi over pi. Well, pi over pi, anything over itself equals what? Equals 1, right? So if it equals 1, let's go over to our bus stop here. 1 we learned when we were little kids, so it's a natural number. It's going to stop at the whole numbers, stop at the integers, and stop at the rational before it gets to school. So we know it is a natural number, it is a whole number, it is an integer, and it's a rational number because it stops at all of the stops. Okay, let's look at 32.45. That is a decimal that terminates, right? It stops. So that is a rational number. Rational numbers don't have any stops before it gets to school, so rational numbers are only rational numbers. Let's look at the square root of 5. The square root of 5 is not a perfect square, so we can't do anything with it other than irrational, so he's a car rider. Remember, don't use I because I is for integer. So actually write out irrational. Let's look at 23. So 23 is a counting number. So that's going to be a natural number. So it's going to stop at the whole numbers, the integers, and the rational. So that one's going to include natural, whole, integer, and rational. So I don't want you to do this one, but I would like you to take a few minutes and pause the video, and I want you to go ahead and work through the other 4 that I've given you here. And when you get finished with those, unpause the video and see if you were correct. Okay, so hopefully you have those done by now. I'm going to go through. Negative 5/6 is a rational number only. Negative 4 3/8 is a rational number only. The square root of 2 is an irrational number. And this negative 8, it is an integer and a rational number. So go ahead and tape this into your iNotebook. Please remember the 1-inch tape rule, and you should be ready for your practice problems.